Okay, in this video I'm going to go over how to factor trinomials where the leading coefficient is not 1. Okay, now there's a method that I was taught by a colleague of mine a few years ago, and it's called the bottoms up method, and she assured me that the bottoms up method was something that they used quite frequently in her previous school in England, and that there is a mathematical reason for it. I'm not going to go over that in this particular video, but I'm going to show you how to use it. And it's really quite elegant. You can get it all done in like 4 or 5 steps at the most. So the bottoms up method, here we go. So when I look at this particular trinomial, I ask myself, is there any common factor that I can factor out? Because you always need to do that first, okay? And I can see that there's really no factor between 3, 10, and 8 that's common. So the way bottoms up works is you take the leading quadratic coefficient and you multiply it by the constant, okay? So let me show you how this works. Step 1, step 2. That gives me now x squared plus 10x minus 24. Now this trinomial is almost always factorable. If it's not, then you can just go back and assume that the original trinomial is also not factorable and it would be called prime, okay? Now this one is factorable, isn't it? I can see a couple of factors, 4 and 6, that seems it might add to 10, 2 and 12 certainly adds up to 10, and actually that's probably the better choice, so let me just do that. I can see that, let me just put the x and the x there, that the positive 12 minus 2 multiply to negative 24, but they add up to positive 10, okay? Now in the bottoms up method, the next thing you do is whatever you multiplied by at the beginning, your leading coefficient, now you have to divide by that coefficient. You have to kind of undo it if you want. Once you do that, this actually reduces, doesn't it? It reduces to x plus 4. This one does not. So in the bottoms up method, you take the bottom of the denominator, and you fraction rather, and then you move it into the front. And now I have 3x minus 2. Checking this, x times x, 3x squared. X times negative 2, negative 2x. 4 times 3x, you get plus 12x. And then 4 times negative 2, you get negative 8. These combine, you get 3x squared plus 10x minus 8. And sure enough, it's the original factor, okay? Or the original trinomial. So let me go through this again now with this second example here, okay? Remember that you ask if there's anything factorable, and I see that there's not, between 6, 23, and 20. So multiply. This becomes, second step, x squared plus 23x plus 120. If you go through the factors of 120, it looks like, let me see, just do this quickly. It looks like it's going to be x, let me go put x here. Looks like it's x plus 8, x plus 15. Remember, you need to divide now by the number that you multiplied by first, and that's 6. So let's do that. Now, this is where a slight variation occurs. Up here, those were all numbers that this one either reduced, this one did not, but these can actually reduce themselves, right? And they also still reduce to fractions. So 8 over 6 is really just 4 over 3, and you have to reduce that fraction if you can. This becomes x plus 5 over 2. Okay? Neither one of those are whole numbers. Take the bottom, move it up, and you get 3x plus 4, and you get 2x plus 5. A quick perusal, quick multiplication, I do something called the smiley face method. Multiply 3x times 5, I get 15x. Multiply times 4 times 2x, and I get 8x. That adds up to 23x, and sure enough, that's in the original problem. These are your factors. Last but not least, let's try this one. Same idea. No common factor. Let's go ahead and multiply the leading coefficient then by the constant. I now have x squared plus 4x plus 48. Are there any factors of 48 that add up to 4? And I really can't think of any. Let me show you what happens here. Let me just do a bunch of pair factors. That certainly doesn't. That certainly doesn't. That certainly doesn't. Getting close, but no, not quite. 5 doesn't work. 6 times 8. Close again, but no, it doesn't work. 7 doesn't work, and then now I just start repeating. So you stop there. So none of these 4 factors, these pair factors, will add up. That tells me that the original is what they call prime. Okay? All right, I hope that was helpful to you. I gave this as a homework assignment for my class, and now here are the answers, guys. Hope you enjoyed.